When my students evaluate this integral, the first thing that they see is this common trigonometric identity, sine squared of x plus cosine squared of x equal to 1. And from here, they see that 1 minus cosine squared of x is equal to 1. And this is correct. And they immediately replace this into our integral here, and they say that this is equal to integration from 0 to 2 pi and square root of sine squared of x dx, and this is correct. And next, what they do, they say that this is equal to integration from 0 to 2 pi of sine x dx. Is it correct? And then they say that this is equal to minus cosine of x, and they evaluate it from 0 to 2 pi, and they say that this is equal to minus cosine of 2 pi and minus cosine of 0. And then what do they get? They get minus cosine of 2 pi, this is minus 1, and minus cosine of 0, this is minus 1. Minus 1 times minus, this is plus 1, and they get the answer to be equal to 0. And this answer is wrong. Why this answer is wrong? The problem is here. The problem is at this level. This level is not correct. Why? Some people are going to ask me why. Let me show you why. Look at the graph of the function sine of x. The sine of x in the interval from 0 to 2 pi here, it has it takes different values. Some values are positive. There are positive values at this interval from 0 to 2 pi, and we have negative values at this interval from pi to 2 pi. And when we evaluate the integral from 0 to 2 pi, what are we aiming to? We are aiming to compute the area. This area is equal to what? The area from 0 to 2 pi, this area which is shaded, is equal to what? And you can see that this area cannot be equal to 0. So this is an indication that this is not correct. Yeah, but why? Because at this interval from 0 to 2 pi, we have positive values. But at this interval from pi to 2 pi, we have negative values. But when we square them, this also will give positive values. That's why I'm saying that, let me show you what I'm saying. I'm saying that this value that we get here, square root of sine squared to be equal to sine of x, this is totally wrong. This should be equal to, instead of having square root of sine squared to be equal to sine x, it should be equal to actually absolute value of sine x. Absolute value of sine of x. So it will be equal to positive at this interval from 0 to 2 pi, and negative at this interval from pi to 2 pi. So you see that now we see that, let me take another color. So now we see that this absolute value of sine x will be equal, let me write it somewhere here. Absolute value of sine x will be equal to positive, will be equal to sine x when we are at the interval, when x belongs to interval pi, interval 0 to pi. And we will have minus sine x when we are at the interval from pi to 2 pi. So that was the problem that my students have not discovered. Yeah, so if we use this concept, our integral now will change, and what are we going to get? If we use this concept, now our integration from 0 to 2 pi of square root of sine squared of x dx will actually be equal to integration from 0 to 2 pi of absolute value of sine x dx, and this will be equal to integration from 0 to pi of sine x dx and plus integration from pi to 2 pi of minus sine x. So this is the right way to do this. So now let's go ahead and evaluate this integral and see that we will not get the answer to be equal to 0, because this area actually cannot be equal to 0. So what are we going to get? We are going to get this will be equal to minus cosine of x, and we evaluate from 0 to pi, and this will be equal to cosine, then plus cosine of x, and we evaluate from pi to 2 pi, and this will be equal to what? This is minus cosine of pi minus cosine of 0 and plus cosine of 2 pi and minus cosine of pi. So this will be equal to what? This will be equal to cosine of pi is equal to minus 1. Then minus times minus 1 and minus times minus, this is plus. Cosine of 0 is equal to 1 and plus cosine of 2 pi. Cosine of 2 pi is equal to 1 and minus times minus cosine of pi is equal to minus 1, like this. So this will give us minus 1 times minus, this is 1 plus 1 plus 1 and plus 1, and this is equal to 4. Yes, and our area will be equal to 4 units. 4 units of area. Instead of being 0 units, so we get 4 units of area. So you see, please don't do this mistake. If you think you have been doing this mistake, stop doing this mistake. When you have a function, in general, when you are evaluating, let me take this a little bit up. In general, the concept is that when we are computing square root of x squared, and if x is a variable, if x is a variable, the square root of x squared is not equal to x. Actually, this square root of x is equal to absolute value of x. So that's the concept. And similarly, square root of sine squared of x will not be equal to sine of x. It should be equal to absolute value of sine of x. So from now on, stop doing this mistake. Do your integral in the right way, and you will get 4 units of area instead of getting 0. I hope you like this video. If you like the video, don't forget to click like the video. And yeah, if you have not yet subscribed to my channel and you wish to see some videos like this in the future, Don't forget to subscribe and turn on the notification bell so that you will get notified anytime we upload a new video. Bye.